Okay, so we're going to take a look at 9.2, graphing quadratic inequalities in one variable. We are going to be taking a look at quadratic inequalities in the form of ax squared plus bx plus c is less than 0, less than equal to 0, greater than 0, greater than equal to 0, where a, b, and c are real numbers and a can't be 0. The solution set to inequalities in one variable can have no values, one value, or an infinite number of values. So what we're going to do is take a look at comparing the equation with the inequalities, and that's because solving a quadratic inequality is very similar to solving a quadratic equation. So we'll first take a look at the equation, and if you recall, its counterpart is x squared minus 5x plus 4 equals y. This is the function. And remember, when we want to find x-intercepts, we substitute in 0 for y, which is why we have x squared minus 5x plus 4. And just recall that to solve for x-intercepts, we factor our quadratic expression and our equation. And we get that x is 1 and x is equal to 4. So graphically, the roots refer to the x-intercepts 1 and 4 because at these points y is equal to 0, right? We're looking for x-intercepts. So we're just going to make a quick sketch of our graph. We know that our parabola will open up because a is positive, and our roots are at 1 and 4, so we'll just write that in. And so our solutions are at these 2 points. Okay, and I can show you algebraically that we do get the expression equal to 0, so I'll just check with x equals 1 and plug that in. And we get 1 minus 5 plus 4 equals 0, so 0 is equal to 0, so that works. And you'll find that when you plug in 4, you get the same results. You get 0 equals 0. Okay, so now we're going to take a look at the inequality and compare that to our equality. Now in this particular one, we have that x squared minus 5x plus 4 is greater than 0, so we have the same quadratic. We're just going to make it greater than 0 instead of equal to 0. Now if you recall, the function form is x squared minus 5x plus 4 equals y, so this expression right here is equal to y. So what we're looking for is where y is greater than 0. Okay? And so that's what this means. It means positive y's. Okay? And so it also means that if we want y's that are positive, we know that that is above the x-axis. So we're looking for values for y which are above the x-axis. Okay? Now to solve the inequality, we still do what we do when we're working with equalities. We factor the expression. We're going to get our roots at 1 and 4. Okay, we are still looking for a parabola that is opening up. Here's our x-axis. We have roots at 1 and 4. But the way we interpret our solution is different this time. So what we're looking for are for x values that make this equation greater than 0, or if you like, where y is greater than 0. That means everything above the x-axis. And so we are going to highlight the part of the graph which is above the x-axis, because that is going to be our solution region. Okay, notice we've got 2 solution regions. We have 1, which is where x equals 1, that goes off to the left. Okay, so it moves to the left. And we have the other region which moves to the right from 4. Okay, and so when we ask ourselves what values of x produce a positive y, the positive y's are located above the x-axis, and in this case where x is less than 1, right, because we're going to the left, and, or where x is greater than 4 because we're moving to the right. So let's check to see if these are correct. All right, we're going to check with x equals 5, so that means we will check to see if this one's correct. Okay, and we're going to pick x as equal to 5 because we want an x value which is greater than 4. So we will plug that in. We will go 5 squared plus 5 times 5 plus 4 is greater than 0. We get 25. Oh, sorry, this is minus, right? Sorry, minus. Okay, minus 25 plus 4 is greater than 0. So we get 4 is greater than 0, and this is a true statement, so we know it is correct. Okay, so let's take a look at what our solution region looks like when our inequality is less than 0. Okay, so less than 0 here means that y is less than 0. It means that we want negative y values. And all our negative y values are below the x-axis, so we are looking for below the x-axis. Okay, so once again, to solve our inequality, we factor. We find that our roots are at 1 and 4, so we make a quick sketch of our parabola, opens up, roots at 1 and 4, but this time we want the region which is below the x-axis. Okay, so this region right here. Okay, and so what x values give y's that are negative? Well, all the values for y which are between 1 and 4. Okay, so how do we write that? Well, if you recall the way we were writing domain restrictions at the beginning of the year, you write the numbers in the order that they appear on the number line, so 1 and 4. Put the variable that you are considering in the middle, and we use less than signs. So we say 1 is less than x, which is less than 4. Okay, now note that in both of our solutions over here where we're looking for where y is greater than 0, and in this question where y is less than 0, we don't have equal to's on our inequality signs, okay? And that's because we don't on the original question. If we did have equal signs on the original questions, then we would include equal signs in our solutions. Okay, so let's check to see if we have the right region here. We say that all of our y values have to be between when x is 1 and x is 4, so let's try where x is 3, which is in between 1 and 4. We will plug that into our inequality and simplify. And we get that negative 2 is less than 0. Well, that's true, so we know that our solution is correct, and we have the right region. Okay, so in the next video, we'll take a look at example 1. Okay, so let's take a look at example 1. We want to solve a quadratic inequality of the form ax squared plus bx plus c is less than or equal to 0, where a is greater than 0. Okay, a greater than 0, meaning our parabola opens up. And the question that we're going to take a look at is x squared minus 2x minus 3 is less than or equal to 0. All right, now notice it does read less than 0 but also equal to 0. So what we're looking at is below the x-axis, but also on the x-axis. Okay, because it says equal to 0 also. So that means that what we're considering is where y is less than or equal to 0. All right, we're going to use the graphical method. We need to factor to get the roots and then sketch. Okay, so factoring is first step and sketching is second step. Okay, so let's factor. X and x, factors of 3, that will give me 2, or 3 and 1. I want minus 3 and plus 1, so my roots are 3 and negative 1. All right, so I want to sketch that. So here is my x-axis. My roots are at negative 1 and 3. I have a parabola that is opening up because a is positive, and so I will sketch that so it opens up. Because it reads less than equal to, and I want where y is less than or equal to 0, I also am concerned of where where y is equal to 0. So when we have an inequality that reads less than or equal to, I use a solid dot at my roots to show that they are included as part of my solution. And remember, the area that I want is below the x-axis, so this is my region. And so I want all the values for x which are between -1 and 3. And so -1 is less than or equal to x, which is less than or equal to 3. And this is my solution. Okay, so I will take a look at method 2 in the next video. Alright, so we're going to take a look at example 1, method 2. This method's probably a little more involved than you need it to be for a quadratic, but it does come in handy when you get to more complicated expressions, so we will take a look at it. It probably will not be your method of choice, but it is good to look at it because if you are going to go on into math, you will definitely see this again. Okay, so our inequality that we're looking at is x squared minus 2x minus 3 is less than or equal to 0. So we are looking for where y is less than or equal to 0, so that means below the x-axis and on the x-axis. Okay, so we already know our roots from the previous question because we've already factored it, so I'm just going to remind you that our roots are at 3 and -1. Okay. So you can do that by solving the related equation to find the roots, but like I said, we've already done it. And so what we're going to do is we are going to plot those on our number line. And because we are dealing with an inequality that is less than or equal to, and we want the values that are also on the x-axis, we're going to use closed circles at -1 and at 3. Okay, so what this does is divide our number line up into 3 regions. Okay, all those values for x which are less than -1, all the values for x which are between -1 and 3, and all those values for x which are greater than 3. Alright, so we're going to use the table below here to organize our information. The first thing we want to do is to write in our intervals. So those are the ones that we found on our number line by dividing our region up into 3 parts. So we have x is less than -1, -1 is less than x, which is less than 3, and x is greater than 3. Now, what we're going to do now are choose some test points from each region. Okay, so for the region which is below -1, we're just going to pick a number that's in that region. I'm going to pick -2 because it's close to -1. And in the region between -1 and 3, I'm going to choose 0 because it's just a nice number to work with. And in the region which is greater than 3, I'm going to choose the 4 because that's a nice number to work with too. It's actually closer to 3. You could pick 5, 6, or 7, but 4 is smaller, so easier to work with. Okay, so what we're going to do, we're going to find out what our y values are for our inequality when x is -2, 0, and 4. So let's plug in -2, and we get 5. So when x is -2, y is 5, we want to know, is 5 less than or equal to 0? And the answer is no, it's not. So we x this region. Okay, it's not part of our solution. So now we plug in x is 0. We go 0 squared minus 2 times 0 minus 3. And we get -3. So when x is 0, y is -3. So is -3 less than or equal to 0? Yes, it is. That means this is probably our region. And let me write that again. That looks kind of sloppy. Okay, when x is 4, what is y? Let's plug in 4. We get 5. So when x is 4, y is 5. Is 5 less than or equal to 0? No, it's not. So this is not part of our region. Okay, so what we can tell from our number line and from our table that we've just put together here is that the interval that we're taking a look at are all those values between -1 and 3. So we can write our solution -1, and remember our inequality has a less than and equal to sign, so we want to include the equal to, so we're going to go less than or equal to x, which is less than or equal to 3, and that is our solution. Okay, and in the next video we'll take a look at example number 2. Okay, so let's take a look at solving a quadratic inequality of the form ax squared plus bx plus c is less than 0, where a is less than 0, okay, meaning that our parabola opens down. Okay, so if a is less than 0, what we're going to do is factor it out, and if possible eliminate the negative coefficient. We're going to take a look at negative x squared plus x is less than -12. Now as you can see, it's not in the form of ax squared plus bx plus c is less than 0, so we will want to do that as part of our first step. Okay, so let's rewrite this as negative x squared plus x, and we want to bring the -12 over to the left. It becomes positive, and then put less than 0. Okay, so we're going to take a look at 2 ways to approach this question. On the first one, we're going to factor the negative coefficient out and keep it. And in the second method, we're going to factor the negative coefficient out and remove it. All right, so whoa, hang on. Okay, so let's take a look at factoring our negative out. So we'll pull that out. That leaves us with x squared minus x minus 12 is less than 0. And then we will factor. And we will get x minus 4 and x plus 3. Okay, now remember this less than 0 means below the x-axis. Okay, where y is less than 0. And we can tell from factoring that our roots are 4 and -3. So we're going to use method 1 that we used above. Going to draw in our x-axis, put in our roots. Okay, remember negative numbers on the left, positive numbers on the right. And we have a parabola that is going to open down, so it will look like this. And notice that our inequality just reads less than, not equal to. So to remember that to show less than but not equal to, we use open circles because we don't want to include these points as part of our solution. And what region are we considering? We are considering the region below the x-axis, and so as you can see we have 2 regions to consider. Okay, we want everything to the left of -3, which means less than -3, and we want everything to the right of 4, so we want everything greater than 4. And so we write our solution as x is less than -3 or x is greater than 4. All right, and we don't put equal to's on here because our original inequality did not have that. Okay, so let's take a look at our second method where we're going to remove the negative sign. So let's take the original inequality, factor out our negative, and to remove it we want to divide both sides by -1. Now remember, when you divide an inequality on both sides by a negative number, that reverses the inequality sign. So we're not going to have less than anymore, we're going to have greater than. Okay, so what we have then is x squared minus x minus 12 is greater than 0. We're looking for above the x-axis where y is greater than 0. So let's sketch our graph. Here's our x-axis. We already know from this question over here that our roots are at 4 and -3. So we put -3 and 4. And we have this time, because our a is positive now on this expression, a parabola that opens up. Okay, and we use open circles at -3 and 4 because we don't include those points. The region that we're looking at is everything above the x-axis where y is equal to 0. And notice that we have two regions again. Okay, we want everything to the left of -3 and everything to the right of 4. So left of -3 are those numbers which are less than -3. And numbers to the right of 4 are numbers that are greater than 4, so where x is greater than 4. And there is your solution. Okay, so we will take a look at some other examples on the next page in the next video. Alright, so let's take a look at example 3, which is our application problem. If a baseball is thrown at an initial speed of 15 meters per second from a height of 2 meters above the ground, the inequality -4.9 t squared plus 15t plus 2 greater than 0 models the time t in seconds that the baseball is in flight. Question is, during what time interval is the baseball in flight? Okay, well let's take a look at our parabola here. Alright, a is negative, which means we have a parabola that opens down. We have greater than and equal to 0, which means we are looking above the x-axis, where y is greater than 0. The question is, why, on the right here, why is the quadratic expression greater than 0? Well, because we want to see where y is greater than 0, and that probably has something to do with the height, right? Because our y-axis is vertical, and when we shoot baseballs through the air, we're probably concerned with height. And so we only want to consider positive y values. All right, because height is positive, not negative. Okay, so our solution. You can use your graphing calculator. You can graph in y1 equals -4.9. Oh, you're going to put in x squared though, right, for your graphing calculator. Okay, now it says here you can use the Quad F program, but I haven't given that to you, so I'm not expecting you to use it. All right, so what are we concerned about when we graph this into our calculator? Well, what we want to know is what our zeros are. Okay, now to do this problem on your graphing calculator, you will want to put in a x-min of 0 and a x-max of around 4. You want to put in, well, probably you want to use an x scale of 1. Your y-min, put in 0, and your y-max, put in around 15, and your scale, probably 0. Or sorry, 1. Okay, and a question before we graph. Why is it useful to know the y-intercept of the graph in this case? All right, well, because at the y-intercept, t is equal to 0, right? That's your x value when y is 0. Okay? And you want to start where t is equal to 0 because you can't accept negative values for t. Okay, so when you graph this on your calculator, we've got 0 and 0. We have I put in into my calculator y max of 15. Okay, this is going to be your height. Okay, in meters. And this is going to be your time in seconds. And when you graph this, you will find that you have a y-intercept at 0 and 2, which you can also tell from your equation here, right? Because if you substitute in 0 for x, you get that y is equal to 2, so you can see that your y-intercept is at 2. And you will, along your x-axis, we're going to go up to 4 seconds, right? So we'll split this up into 4. And we have a vertex at 1.5 and 13.5, so around here. Okay, and when you find your 0, you should have a 0 at 3.2. And if you have any of your negative y values showing up over here, you'd have another 0 at negative 0.1 and 0. But you know that you would discard that one, right? Because you can't have negative time, so that one is out. Okay, so let's sketch this in like this and down to here. Okay. And we want to use, okay, our solution is the region that is above the x-axis, okay, where y is greater than 0. So what we're concerned with then is the whole part of the parabola, which is above the x-axis. Now, because it just reads greater than, right, on our inequality, we have an open circle at 3.2 because we don't include that, all right? But we do include our y-intercept at 2, okay? All right, now what I would expect from you when you're graphing these is to make sure that you label all important points. Okay, and so what do you think our solution is? All right, well, if you take a look at our graph, everything above the x-axis, okay? And because our solution is a region that's connected between 2 points, okay, we're going to use only one statement, okay? And notice that the first point that shows up on our graph is at 0 and 2. And our x-coordinate at that point is what's important here, okay? And at the other end too. And so when we write our solution, we go from 0 seconds to 3.2 seconds. Okay, so that's how we'd write our solution for this. And we're not going to include equal to, all right, because if you take a look at your original inequality, it just has greater than and not equal to, okay? All right, so what does this mean? Okay, well, it means that the baseball is in the air from 0 seconds all the way to 3.2 seconds, okay? So when you answer the question, during what time interval is the baseball in flight, you say the baseball is in flight between 0 and 3.2 seconds. Okay, so this concludes our notes for section 9.2. Alright, so let's take a look at an example where we cannot factor. So what happens? Well, there's no problem. We're just going to use other ways to get our roots, and the one that you are most familiar with is the quadratic formula. So that means we need to know what a is, and in this case 1, and b is -2, and c is -4. So let's plug that into our quadratic formula, which is -b, so -2 plus or minus b squared, so -2 squared minus 4 times a, which is 1, times c, which is -4, divided by 2 times a, which is 1. So that gives us minus -2, which is +2. Simplify which in the square root bracket, which is 20, divided by 2 times 1, which is 2, and so we find that x is equal to 3.2 and x is equal to -1.2. Okay, so we've got less than or equal to 0. All right, that means below x-axis and on the x-axis. Oops. X-axis where y is less than or equal to 0. So let's do a sketch of our graph. We have roots at -1.2 and at 3.2. We have a parabola that opens up because a is positive, so we graph a parabola that opens up. And we want to include our roots because we need our points that are on the y-axis, so we include -1.2 and 3.2 as part of our solution. And we want the region which is below, so we graph and shade that region below. And so you can see that we want the values between -1.2 and 3.2. Okay, and don't forget, because our original inequality is less than or equal to, we include equal to in our solution. Okay, there's some practice problems below. I'm not going to do the first 3. You can do them on your own. Here are your solutions, so you can practice them and see if you get those answers. And I want to take a look at D and E and a third one, which I will call F, which is x squared plus 4 is less than or equal to 4x. Okay, now D and E are related. Okay, notice they're the same inequality. The only difference is that on the first one we want what's below the x-axis, and on the second one we want what's above the x-axis. Now, neither one of these is factorable. Okay, so we're going to sketch our graph using a different method. And I know that this is a parabola where the vertex is at 0 and -4, okay, because it's in the form of y equals a times x squared minus q. Okay, so we don't have a p-value. P is 0, and in this case q is -4, so our vertex is at 0 and -4. Now our a is negative, which means we have a parabola that opens down. So when we sketch this, we have a parabola that has a vertex at 0 and -4, and it opens down. Now if you take a look over here, we want below the x-axis, right, where y is less than 0. Notice our whole graph is below the x-axis, so we're considering the whole region. Okay, so everything is below the x-axis, which means that our solution set is all real numbers. So x is all real numbers. Okay. All right, so what happens to our solution when we want what is above the x-axis? Okay, well, we already know what the graph looks like. We know we have a vertex at 0 and -4. Okay, but because we're concerned with the region above the x-axis, we don't have anything there. So if you're thinking that our solution is no solution, you are correct. And remember, you can write it like this. Okay, so let's take a look at f. We need to put it in the form of ax squared plus bx plus c is less than or equal to 0, so we need to move the 4x to the left. It becomes negative. Okay, so this means below x-axis and on x-axis. Right? We want where y is less than or equal to 0. So let's factor. And the factors of 4 that will give you 4 are 2 and 2. We want minus 2 and minus 2. And notice we've got two equal factors, so our root is 2. All right, so let's graph this. Here's our x-axis. Our root is at 2. We have a parabola that opens up because a is positive. And remember, we want to include as part of our solution whatever is on the x-axis, so in this case 2. And notice that no part of the parabola is below the x-axis, so our solution region is just going to be where x is 2, and so we write that our answer, our solution is x is equal to 2. Okay, and that concludes this discussion.